Okay, so we recall a bit on the Schmitt trigger. So we replace the V out. Okay, this particular V out. I'm sorry. Okay, so we replace this particular V out. Okay, with plus minus V saturation. So now V UTP upper trigger equal to 8.67. Okay, VLTP, when you replace V out with negative V saturation, you will get negative 4.67. Okay, so the question asks you the transfer characteristic curve and also the output waveform. So the output waveform, you need to apply the comparator method, okay, like you have done in the comparator. Okay, so the transfer characteristic curve is where you have this kind of curve. So this is the transfer characteristic of Schmitt trigger. So where you have the VUTP as well as the VLTP. So this means that the range of your Schmitt trigger cannot be beyond than this VUTP and VLTP. All right, so it may exceed the VUTP point, this point up to here, but when it go back to VLTP, it must not exceed the VLTP point over here. So the range of the transfer characteristic is between VLTP and VUTP, and the minimum and maximum point, of course, the V out plus V out saturation and negative V out saturation. If this question asks you the transfer characteristic curve of the Schmitt trigger, so this is how it looks like. Okay, since you have your VUTP is negative, okay, negative 4.67 volt. Okay, so this is the value for your VUTP is negative 4.67, and plus VUTP is equal to 8.67. Okay, 8.67. Therefore, this is 8.67. So your transfer characteristic curve of this Schmitt trigger cannot be less than VLTP or greater than VUTP. Okay, so this is how it looks like for the transfer characteristic curve. But for the output waveform, okay, output waveform, you need to apply the comparator, which is this by applying this condition. Okay, this condition. All right, right, right. So this condition. Okay, so you need to know your V in. Your V in is actually connected to the V minus. So your V in is 10 sine omega t. So at this node, the V in is 10 sine omega t. All right. So your V out, not V out, okay, your V minus is V in, 10 sine omega t. Your V plus, now you have two value, okay. In the comparator, you only have one value. In Schmitt trigger, you have two value, which is upper trigger and lower trigger. So when you make comparison, you have to consider both, okay, both. All right. So now let's take a look here. All right, so you have your V in is equal to the V negative, this one. Okay, and also your V plus, okay, you have two value, VUTP and VLTP. So you have V plus at V upper trigger, 8.67 volt. And you also have another one. Let me change my red color so that it will be standardized. So this is also V plus, but lower trigger. Okay, lower trigger. All right. Okay. So now let us make comparison with the most significant difference. Okay. So this is, you have over here this portion. Okay. All right. So I change color to green. Okay. This portion. So this portion, so let's take a look on this portion. So this portion, so V in is the V minus, okay? At this particular point, your V in, which is your V minus, is above VUTP. It only intersect with the VUTP. It doesn't to do so. This region, the green region, okay, you can see green, right? Okay, the green region over there only intersect with the VUTP. Therefore, you make comparison with VUTP. Okay, so now your V minus is above the VUTP, which is the V plus. Okay, so this satisfy which condition? The first condition or the second condition in the table over here. So which condition it applies? Okay, for this green region. So this green region satisfy the second condition, which is V minus greater than the V plus. Therefore, V out equal to the negative V out saturation. All right, negative V out saturation. Okay, so that's why you get this point. Okay, negative V out saturation. Okay, so let's take a look on the next one. Okay, on the next one over here. Let me take my color, the purple. So this purple. Okay, so this region now it intersect with the VUTP as well. Okay, therefore, now VUTP, which is the line of the V in now, which is the V minus, is below VUTP. So this one satisfies V minus less than the VUTP, which is satisfy the first condition where V saturation, V out equal to the V plus saturation. That's why you are getting this value. Okay, this value. So you have the line. I don't want this. Okay, so this value. So that's why you get a plus V out saturation, and you have V minus. All right. So the actually you have this line. If you can see over here, you have if I make this line, so you also have this line. Okay, but then this line is in between, so it touched to VUTP, as you can see at this node, and also it touched at this node VLTP. So for this particular point, if you look at the transfer characteristic, okay, between VUTP and VLTP, so it will take the previous value. Okay, it will take the previous value. Therefore, from this point to this point, it will take the previous value, which is negative V out saturation. Okay, that's why I go a straight line over here. It is negative V out saturation up to this point. Okay. All right, so we remember that. So for this particular region, okay, it touched to VUTP and VLTP. Therefore, you take the previous value. Okay, in this case, the previous value is negative V out saturation. Okay, there you go. You find another cycle. So I make it as a blue color. So this cycle, okay, this cycle. Okay, for this region, it only touching VLTP. Okay, VLTP. So in this case, VLTP is the V plus, but still this line, okay, still this line is equal to, so this line is still equal to the V in, equal to the V minus. So can someone give me the condition? Is in this region V minus less than the VUTP or greater than the VUTP, which is VUTP is V plus. Can someone give me? So in this case, V minus greater or equal than the greater or less than the V plus. Look at that.
Less than.
Yes, less than. Okay, means someone is awake in my early morning class. Thank you. So V minus less than the V plus. So this one satisfies which condition? The first condition or the minus the second condition?
First condition.
Yes, first condition. Therefore, the V out is equal to the V plus saturation. That's why we have a straight line over here. Okay, but your line is supposed to be up to here. Sorry, up to here. Up to here, yeah, right, until it reached the second one here. Okay, but then in this case, it touches two VUTP and VLTP. Therefore, your output must follow the previous output. You will have a straight line up to this next cycle. Okay, so you will get your output like this until here. Okay, there you go. You follow the next cycle, which is plus cycle. This is the same like previous one. You don't have to compare. You just take the same value, which is supposed to be the negative V out saturation. Up to the next cycle, it will continue until it reach like this. All right. So that's it for the Schmitt trigger output waveform. Okay, so this is transfer characteristic curve. Don't mix up with it. Okay, so this is transfer characteristic. Okay, so this is the output waveform. All right. Okay, I think that's it. Okay, so any question regarding the Schmitt trigger before I move forward on the tutorial multi-stage? Do you have any question regarding this? Some of you asked me yesterday, private message. I think today much clearer as this line should be on the line, okay? This line should be on the line here. Here. This one should be on the line. Yes, like this. Okay. All right. Okay. All right. Any more question? Very clear? Everyone? Everyone?
Yes, Doctor.
Right. Okay. All right. Great. Okay. All right. So, okay. I think that's it for the Schmitt trigger. Okay. I will stop the recording because I don't want to mix up so I will post two video today. Okay. So for the Schmitt trigger and for the tutorial. All right. All right. So let's take 5. Okay. And then we continue on the tutorial. Okay. So take out your tutorial multi-stage. So I'll also upload this lecture slide today just for your review, okay? But it is actually the same thing, but that's okay.